Spectrophotometry is an experimental technique that used to measure the concentration of solutes in a specific solution by calculating the amount of light absorbed by those solutes. This technique is very powerful because certain compounds will observe different wavelengths of light at different intensities. By analyzing the light that passes through the solution, it can identify particular dissolved substances in solution and how concentrated substances those are. A spectrophotometry is the device that also used to analyze solutions in a laboratory research settings. Now I am going to explain how to operate spectrophotometer step by step. First step, which is turn on the spectrophotometer. Most spectrophotometer need to warm up before they can give an accurate reading and results. So turn on the machine and let it warm at least for 15 minutes before running through any samples. Next step is cleaning the cuvettes. It is it is important that cuvettes must be properly cleaned before use. Rinse each cuvette with deionized water. To get an accurate result, it must be cleaned before use. Without cleaning the cuvette affect the reading of will affect the reading later on. It must be handle the cuvettes proper and safety way because most cuvettes are made from glass or quartz. Take care with cuvettes because it quite be expensive, particularly cuvettes that made from glass because it can easily brokenable. Usually, cuvettes are designed from quartz used in UV visible spectrophotometry. There are several safety precautions that need to follow while handling cuvettes. First, avoid touching the sides that will light pass through, generally the clear sides of the surface of cuvette. If accidentally touch these sides, wipe the cuvette down with a Kim wipe, which are formulated to prevent the scratching of surface of cuvette. Third step is load the proper volume of sample into the cuvette. Some cuvettes have a maximum volume of 1 milliliter, while test tubes may have a maximum value of 5 milliliter. As long as the laser producing the light is passing through the liquid and not an empty part of container, it can get an accurate reading and also result. If using a pipette to load samples, make sure that use a new tip for each sample to prevent cross-contamination. Later, it would affect the reading of spectrophotometer. Fourth step is prepare a blank sample. Chemical solvent, also known as blank sample, has only the chemical solvent which the solid to be analyzed is dissolved in water or not. The blank is the same volume as the solution to be analyzed and kept in the same kind of container. In this spectrophotometry, we use water as a blank solution. Before placing the cuvette in spectrophotometer, Please ensure that the cuvette surface is clean as possible. To remove the water droplets or dust surrounding the surface of cuvette, use lint cloth to clean the surface of cuvette smoothly to remove the dust or water droplets. Now I am going to explain how to running the experiment using spectrophotometer. First, choose and set the wavelengths of light to analyze the sample. Next, set the desired wavelength according to the specifications of spectrophotometer. Now I am going to explain on how to set wavelength in spectrophotometer. First, press wavelength button and then set the wavelength required, which is 800 nm, and then press enter button. Now put two blank into the groove place, then shut the lid. Okay, now press the auto zero button. After this, one pop-up sound will hear. After the pop-up sound, take out one blank cuvette and replace it with sample and shut the lid, then press start button. Okay, now the reading of absorbance will now the readings of absorbance can be recorded. Now I am going to explain on how to set wavelength for 800 nm from 800 nm to 600 nm. For this, press 2 button to select the spectrum, then set 600 nm to 800 600 nm from 800 nm. For this, press 800 nm, then followed by 600 nm. Then press auto zero button. Now the pop-up sound will hear. After the pop-up sound, press the start button. Now the absorbance of 600 nm 600 nm wavelength will come out and the absorbance can be recorded. Second, calibrate the machine with blank. Place the blank into cuvette holder and shut the lid. Record this value in case need for later on. When remove the blank, the calibration will still be in place. When measuring the rest of samples, the absorbance from the blank will automatically subtracted out. Next step, remove the blank and test calibration. With blank removed, the reading should stay at 0. Place the blank back into the spectrophotometer and be ensured the reading not change. If the machine is properly calibrated with blank, everything should be stay at 0 reading. If the reading is not 0, repeat the calibration steps with blank again. Fourth step, measure the absorbance of sample. Remove the blank and place the sample into spectrophotometer. Slide the cuvette into the designated groove and ensure it stands upright. Now record the values of transmittance or absorbance. Repeat the reading for sample at least 3 times and get an average. This ensures a more accurate readout. After getting the transmittance and absorbance reading, calculate the transmittance and absorbance of sample. Transmittance is how much of light passed through the sample reached the spectrophotometer. Absorbance is how much of light has been absorbed by, by one of the chemicals in the solute. Transmittance is found by dividing the intensity of the light that passed through the sample solution with the amount that passed by blank solution. T equals to I divided by I0, where I is the intensity of sample and I0 is the intensity of blank solution. The absorbance is expressed as the negative of negative 10 logarithm of the transmittance value A equals to negative log 10 t. Example, for a t value of 0.1, the value of A is 1, meaning 10% of the light is transmitted and 90% of light is absorbed. After that, plot the absorbance value versus wavelength graph. The absorbance value is plotted on the vertical y-axis against the wavelength of light used for a given test plotted on the horizontal x-axis, and compare absorbance spectrum plot to know plots of specific compounds. Compounds have an unique absorbance spectrum will always produce a peak at the same wavelength of every. That's all from me for today. Thank you.